Hi, I'm Isabel Allen, Editor of Architecture Today, and welcome to part 2 of Rethinking Resi. This session on sustainability is produced with content partners Knauf Insulation. We have 4 presentations coming up. Alex Ely from May is going to show how passive house design principles have been applied at Agar Grove in Camden, the largest passive house development in the UK. He's also going to run through some of the lessons learned from the first phases and suggest how these might inform the next phases of the project. Krista Devan from Arup is going to share insights and predictions about the way decarbonisation is likely to impact on the built environment in the future. Matthew Prowse from Knauf Insulation is going to run us through the new improved Document L and its implications for residential design. And finally, Marion Bailey from PDP is going to present a series of case studies that illustrate the long-term environmental costs and benefits of retrofitting our existing housing stock. We'll be holding a Q&A discussion with all 4 speakers at the end of the session. And now I'm delighted to introduce our first speaker, Alex Ely, who's the founding director of May Architects.
Well, thank you. I was going to first off introduce you to May and our work and how we sort of fit with the questions we're being asked about the challenges and opportunities to increase housing supply and alongside delivering housing in places where people want to live. And then focus on a particular area of interest or growing interest of ours as a practice, which is delivering low operational carbon buildings. And I'll illustrate that with a case study of a scheme where we've recently completed the first phase and in its ongoing project that's where future phases are still under construction, and that's Agar Grove. So who is May? We're an architecture practice, really very much focused on public housing in principle, but also the social infrastructure that goes with that. And really for us, that's what's key to making places work. And I guess our overarching goal is really to create buildings and places that uplift the human spirit. And that's guided by 3 principles. Our work is social, so we're always focused on creating inclusive, welcoming places together with the people who use our buildings. So we do a lot of engagement. Really lucky to work with the people who ultimately live in the homes that we design and build. Our priority increasingly is to respond positively to the climate emergency by designing resilient and low carbon buildings, and that's both embodied and operational carbon. And then we try and go beyond sort of convention, particularly spatially. So really for us, in answering the question about creating homes that where people want to live, it's very much about creating spatial delight and places are enjoyable and welcoming. So just an illustration of some of the range of work that we're doing. This is some of the estate regeneration schemes we've been doing across London. Pretty much all our work is in London, and it's mixed tenure in some instances. So Brentford Lock on the right, top right, which is 40% affordable. And then the other sort of middle and top left are Regent's Park, which were 100% affordable to deal with rehousing tenants who were losing their homes as a result of HS2 construction. So we worked closely with them and with Camden to find new opportunities for them to stay within the neighbourhood in new homes. But also increasingly working in specialist sectors, so dealing with later life housing, bottom left, Grenadier House, which is for Pegasus Life, and that's dealing with housing for those in need of suitable accommodation in their later years. But I want to talk specifically today about the climate challenge and the fact that we need to ensure that all new buildings are operating at net zero by the year 2030. And so I want to start with our reflections on how we can do that simply in housing. And a lot of you will probably be familiar with passive house design, but for us on Agar Grove, it was relatively new. And it's relatively simple, but the execution is hard. So passive house relies on some simple moves. first one is about orientating the buildings so that they warm up naturally from the sun. So your ideal orientation is towards the south, which I'll come on to is quite hard to achieve in urban settings. And I think one of the challenges today, if we're going to build sustainably, we want to be building in urban conditions, in cities, intensifying cities, where you want to build at a suitable density that arguably simple south-facing orientation doesn't necessarily lend itself to good urban design. So we'll talk about some of that, the challenges of dealing with that. The second aspect of designing to passive house is ensuring that there's good solar gain into the home, so it naturally warms up, but importantly has suitable shading and suitable sized windows so that they don't overheat, but also that windows are appropriately proportioned so that you're not reliant on artificial light during the day. And we've again learnt through the Agar Grove project what's working and what's not, and certainly sort of lessons for future. Simple and effective form factor helps reduce the heat loss, and more complex building envelopes tend to be less efficient in terms of their form factor and therefore increase heat loss. So how do you create beautiful but relatively simple forms without kind of dumbing down to simple boxes? And then the sort of core element of passive house is about airtightness and really ensuring that you're not leaking heat and through drafts and poor construction. And that overwhelmingly is often where buildings perform badly, is the sort of permeable construction or their leaky construction. So even things down to things thinking like how you design in letterboxes, or rather don't, and manage that so that there's not leaking through letterboxes or cat flaps. But it's about ensuring that buildings are well built, so really keeping a close eye on form of construction and ensuring that there's very high level of insulation, so super insulation as a way of minimizing heat loss and improving the warmth of the home. And then the sort of complementary element of passive house design is to ensure that there's sufficient air for health and well-being. And we do this through mechanical ventilation and heat recovery. So your damp air from kitchens and bathrooms is the moisture is extracted and emitted, but the actual warmth from the heat can be put back into the home, so it's not wasted, and ensuring that there's sufficient ventilation. And it's important to note that whilst airtightness is important, passive house isn't about hermetically sealed homes. You can open windows but for natural ventilation, but ideally in winter you don't need to. Now, the RIBA have set out very clearly a challenge for us all as architects and those in the built environment to reduce operational and embodied carbon. And through the passive house, I'm really just focusing on the operational element. And a typical home today built to standard building regulations is the operational energy needed is about 120 kilowatt hours per meter squared. And the RIBA's 2030 target, in order to meet our carbon reduction targets, is 35 kilowatts per hour per meter squared. And passive house, for example, at Agar Grove, what we've achieved there is 15 kilowatt hours per meter squared. So way beyond the 2030 climate challenge target. And I think it's probably, perhaps for others, given my time, for others in another session to talk specifically about embodied carbon, which I haven't got time to go into, but I'm going to focus on the passive house element of operational energy in Agar Grove. So Agar Grove was a collaborative scheme developed with Hawkins Brown Architects as co-master planners, along with Grant Associates, and then with Arcadis as project managers and QSs, Stantec, Max Fordham's bringing real specialist expertise in terms of services and sustainability. And then we worked with Warm as Passive House certifier, and then also Hill, the contractor, brought in Archetype for their specialist passive house knowledge as delivery architects. And it's a classic 1960s estate, and you can see the sort of grain of these buildings here doesn't respond in any way to the urban context. There's the sort of Victorian and Georgian context to the north, which is much more about streets and squares, and the classic 60s estate turned its back on that character, and the buildings were substandard. They were low quality construction. They were undersized in terms of meeting decent space standards, and it was deemed through an engagement process that residents sought new homes rather than refurbishment. And you can see from David Grandorge's beautiful photos here what the estate looked like. The low-rise buildings had no relationship to the outdoor spaces, so no active frontages onto the street. And again, the tower meets the ground very poorly in terms of its urban design. However, we are looking to retain the tower, so that will be stripped back to its frame, again keeping the embodied carbon that's already in that building, and it'll be extended and reclad as new housing. And early days, we look to kind of balance that consideration of part retention and refurbishment and part demolition. But you see from the context to the north on Agar Grove that you've got wonderful kind of Victorian villas, and on the left the estate very much turns its back to the street and has no sort of connection to the urban realm. So our master plan, this is where it's a sort of challenge meeting passive house, because you can see it's not just orientated east-west in order to optimize solar gain. We've got streets running north and south, and the master plan was very much about extending the green spaces on Agar Grove, so improving the public realm. It was about stitching in and connecting the streets into their context, retaining Lulworth Tower and giving that new meaning by situating it within the new master plan, creating a safe family neighbourhood of streets with continuous frontages, so active frontages and front doors onto the street, and then importantly creating better homes for the residents who are being rehoused. So nobody was displaced off-site, everyone was offered a new home on the estate to better space and environmental standards. And here you see the existing buildings on the top left. So the brown were retained and the red were demolished. We open up new routes and connections, albeit the site is bounded on two sides by the railway to the east and to the south. So there's kind of limited scope to create a proper permeable network of streets, but the intention is still very much to knit it in as best we can. And then the scale increases towards the south. So on the north, we've got villas that face onto the existing villas opposite, and then building up height towards the railway where we can deal with the density. So here you get a better overview of the sort of mix of typologies that we're offering. So we've got terraces, villas, and mansion blocks, and then a new tower block at the back that replaces, or rather rehouses, the residents who are currently in Lulworth Tower. And then Lulworth is the last phase, and that can be refurbished and offered up as market sale once all the existing tenants have been rehoused. And so really what we're trying to do here, and very much responding to sort of the brief for today, is about creating places rather than just housing, is through the variety and the mix of housing on this estate, create a rich mix and a rich place of diversity in terms of diversity of building type, diversity of housing type, and diversity of tenure. So the actual buildings are 50% designed by Hawkins Brown, 50% by May, but dotted throughout the scheme, so we get that variety. But we coordinated with our friends at Hawkins Brown a material palette from the outset, which is sort of mineral-based material palette of bricks, which are very much sort of part of the urban context, and albeit with a variety of colours and textures. So just to give you an overview of the statistics, we had 249 homes on the estate. So there were 210 Camden tenants that we worked very closely with to rehouse and ensure that we were designing to their new housing needs. Some of them were in over-occupied homes. And what we've provided in the scheme is 507 new homes, of which 50% are market sale, and that provides new income to pay for the re-provision of the affordable. And as you can see from the diagram on the bottom right, again, tenures are distributed throughout the estate. So to date, we've completed phase 1, which are the areas dotted in red. Phase 1A was designed by Hawkins Brown, and that was on the one available site. So that was on a car park, and we were able to build that in order to then move the first group of residents into it and do the first phase of demolition. And then that started the cycle of rehousing and redevelopment. So this is Hawkins Brown's building, which comprises 38 social rented homes. And you can see Lulworth Tower in the background. And just dealing with the sort of passive house moves, you can see that on the right-hand image, it's very generously glazed with large balconies that help provide overshading of the homes, preventing overheating rather. And then on the north, more heavily sort of fenestrated elevation with more insulation and more mass to reduce the heat loss. So we've designed to ensure that homes are optimized for dual aspects, so there's good cross ventilation. And here you can see from this plan from phase 1B, which is our buildings at May, you can see that the buildings are through flats or through maisonettes. So this phase 1B comprises 23 market sale homes on the end here, this building here, which you see in the left, and then additional social rent, which I'll show in the next image, in the 2 terraces off it. And they all share a communal garden on the inside. So all residents have access, regardless of tenure, to that communal garden. And you can see that at ground, there are duplexes with through rooms and dual aspect, and then a mixture of maisonettes and duplexes above. And with these market sale homes, we've designed them as split level. So building on the history of Camden social housing and public housing under the Sidney Cooke's era, he pioneered with architects like Benson Forsyth, Neve Brown, some very interesting typologies that we were keen to explore further for today. So these split level homes kind of have real spatial delight and real qualities in terms of light and air. But you can see from this diagram that they're quite challenging to achieve passive house. So this just talks you through how we applied those principles that I showed you earlier. So thermal airtightness, triple glazing for the windows, biodiversity on the roofs and photovoltaics for renewable energy, shading from the balconies, and then MVHR for the ventilation and heat recovery. And then the additional building behind that is Hazelbury Way. So this is delivering 14 social rented homes. And what you're looking at here is double stacked maisonettes. So you've got a tier of maisonettes which have their front door onto the street or the play area that you're looking at ground and first. And then the upper story of maisonettes are accessed of a gallery at the back. So at the left-hand end, you've got the entrance to those, and you go up a stair to a gallery at the back, and then you've got a duplex above, expressed in these very large, almost dormer-like forms. And then the last phase to be built is the buildings on Agar Grove itself, and this comprises 20 social rent homes. Again, you've got dual aspect, so you can see from the photo really good quality of light and internal glazing that just again helps get light into the depth of the plan, as well as wonderful views through. And then in this building, you've actually got a duplex with its front doors onto the street, and then a triplex where you come into the middle floor, so at third floor, and then you either go down to the bedrooms on second floor, or you go up to the living room, which is set back behind the parapet. So all these homes, you can see we're trying to design principles of good urban design, good dual aspect, and sort of generous glazing. I think certain lessons that we've picked up, we probably wouldn't maybe do floor to ceiling glazing again like this. I think the efficiency of the sort of lowest zone of windows is the relative heat loss to light gain is not doesn't really sort of justify full height windows. So we'd probably look to raise the sill heights in future. I think we've also learnt that balconies can perhaps be simpler, and I think there is a case to be made for simpler either self-supporting balconies or bolt-on balconies rather than inset, which increases the form factor. But nonetheless, we achieved really good performance on this. This building that you're looking at achieved a 0.3 air changes, 50 pascals, and that's half the normal passive house airtightness. So you can deliver airtightness in urban settings to a good density with layouts that respond to the site orientation, but you also but it's important that you manage that through the design. So just some observations to wrap up. I think we didn't start out with any great knowledge of passive house when we started this project back in 2013. And so there was definitely an upskilling on our part and working closely with other consultants and advisors. And I think the whole team effectively had to go on a journey, as well as the client, although Camden, to their credit, had already built one passive house scheme in another part of the borough. So they already were committed to that, and they saw not just the environmental benefits of reducing carbon through operationally, but also reducing fuel poverty, which is often something that their tenants suffer, especially those on very low wages or unemployed. And it's great to be able to deliver environmental as well as social sustainability through passive house. I think I would advise that you do need to allow or advise the client to factor in additional costs such as the passive house assessor and certifier. And also there is extra time needed as architects and consultants to design, which I would advise requires a modest fee uplift to accommodate that. Do allow sufficient time through the programme, especially at the early stages, and importantly, make decisions about passive house at the early stages, because the more you can address those requirements like form factor or an orientation early on, the fewer problems you'll have later on. I think the industry is catching up, but there is a cost uplift and to deliver the high performance needed. Although social landlords like Camden can factor that into their long-term operational costs, so reducing the heating bills, reducing fuel poverty, it clearly makes sense for public landlords. Hill have been remarkable. They've done a very good job as contractors, and again, they hadn't done passive house before, but really worked hard to ensure that the performance worked well in the first phase, and they have subsequently been appointed to do the next phase as well. Personally, I'm not sure that design and build is necessarily the best contract for delivering passive house, but it tends to be the preferred one for housing. So therefore, I would suggest at least a strong monitoring role during construction to ensure that issues are resolved. So on that note, I will pass back and thank you for your attention. Happy to answer questions.
Thank you for that, Alex. It's really inspiring to see the Borough of Camden championing such an ambitious project. I'm interested that you talked about the homes at Agar Grove as being inspired by the sorts of housing built in Camden in the 60s and 70s when Sidney Cook was borough architect. So are we seeing a return to the glory days of strong design leadership at council level, do you think?
Well, good question. We're building barely a fraction of what we were in Sidney Cook's era, about 6,000 council homes a year compared with, I think, 150,000 at the height of the public housing programme. But it is a changing scene. The government have introduced fiscal incentives by lifting the housing revenue cap in 2018, which has enabled a lot of local authorities to start building again. And they are skilling up and bringing in experience from other sectors or from housing associations or private developers, but also outfits like public practice. You know, the public practice initiative has really brought in a sort of interest in design and architecture into boroughs. So yeah, I think it's all heading in a good direction.
Good, and on that optimistic note, I've got to move on. Alex will be joining the Q&A session at the end of part 2, and he'll be happy to answer any questions you might have then. But now our next speaker is Krista Devan, who is an associate sustainability consultant and mechanical engineer at Arup.
Okay, thank you very much. So I will be talking about buildings for the future, and then especially how decarbonization is going to influence the future of buildings. So how will the decarbonization path that is projected by the Paris Agreement influence our built environment? So the built environment is influencing this decarbonization path majorly. So about 40% of the carbon is from the built environment, and it consists of two parts. It's energy and materials. So I will be talking about how these two parts influence the built environment and how it's going to change. And actually, this change is not as logical as it sounds, because if you look at the past 30 years, the construction sector isn't really known for being rapid in changing. So, for example, if we look at the productivity in the last 30 years, then not much has changed for the construction sector, and it only changed for the worst, actually. So if not much has changed in the last 30 years, what will change then in the next 30 years? And is sustainability powerful enough to change that? So to understand that, it's interesting to look at a different sort of asset, which has been impacted by sustainability in the last couple of years. And that is the oil and gas firms. So in 2016, a record number of oil and gas firms got bust, and that was due to the renewable energy revolution. So what we've seen from then is that really there was a big change in the public opinion against oil and gas firms. And what we also seen is that reputational damage was going to lead to investment funds shifting their investments away from oil and gas. So there was a really big financial influence on this sector. So basically what we see here is that this asset got stranded, is what they call it. And there hasn't been a lot of research about different other industries of assets that got stranded until the recent years. So what we see from this research is actually that the built environment is of a higher risk of getting stranded. So it's a higher risk than upstream oil and gas. And what we also see from this research is that a delayed action will actually increase the negative impact. So the sooner we start with this transition, the better also financially it will turn out. So what is interesting is to look at this big decarbonization path and how this influences portfolio and individual assets. So for example, if you look at this CRISP analysis, we looked into a portfolio of a number of buildings and looked into when they got stranded over time, and also what the gap would be between the portfolio and the decarbonization targets. So what is interesting about turning this into looking at it from individual assets is that we really can see what is happening and can start to translate this abstract decarbonization towards real KPIs that are understandable for real assets, so that we really know what to do for individual buildings and also know where to start and how to prioritize these. So this impact on the financial aspects of the built environment, this is also already starting to happen, and that is related to, for example, energy labels. So what we see at the moment is that financial institutions see the energy labels for buildings, especially the buildings with a low energy label, as a big risk for financial investments. And this is starting to expect to grow when EU taxonomy takes place in the next couple of years, and it's starting to establish. And the EU taxonomy is a law that is trying to reorient capital flows towards sustainable investments. So what actually this in short means is that it will become more attractive to invest in sustainable real estate than in unsustainable real estate. These energy labels are really focused on theoretical performances of buildings, and this is something different than actual performance. So for example, if we look at this graph, then here on the bottom you see the theoretical performance, and all these dots are buildings. And then, for example, this building is a A++ building in theory, but then actually how it's performing, it's worse than a G building. So on paper it might be A++, but in reality, when you look at the energy meter, it's actually worse. So what this really means is that this building is really underperforming, and what this also means is this is actually one of the newest buildings. So this is something that we see in more researches, that new buildings tend to underperform more than older buildings, because new buildings tend to be more complicated than older buildings. So what is important is that we already start designing buildings so for the fact that they use less energy, so that we take natural elements as an input for our design and really start to shape our buildings around them consuming less energy. And that counts for the building shape, but also for the building envelope. Again, these can really take the natural elements to, from a first instance, already start to reduce a lot of energy. So a second thing that is really important is that we also start to collect data from our buildings and really start comparing that to an optimal performance of a building, so that we can really pinpoint underperformance. And a way to do that is by building a digital twin, which is really a mathematical model of the building, really mimicking temperature flows and energy flows in a building, and which can really indicate where changes start to happen. And this is like the leverage point for really using machine learning in buildings and really getting to a big step in smart buildings. So this was about energy, but when we look at materials, things are a little bit more unclear. So the EU hasn't set any clear targets for circularity. So some of the member states have done that. So this is, for example, the targets that the Netherlands has put into place: 50% circular and 100% circular. But if you look at where we are now, we're actually at 8.6% according to the Circularity Gap report. So whatever targets there might be, it's going to lead to a major change. So putting this into relationship to this asset stranding, what I just talked about, it's really interesting to see what would that mean for asset stranding if we really have such a major step to go in the next 30 years. And also when you put this in a relationship to actually our global consumption of resources will need to grow in the next couple of years to 90% by 2060 compared to 2017 values. And this in a context in which Europe is really dependent on other countries. So for our critical raw materials, we are pretty much dependent on Russia and China, especially in the political climate that we're now in. It really pinpoints that we really need to take care of these critical raw materials. And also in the relationship of the energy transitions, these materials are mostly needed for technologies that are required for this energy transition. So it's really important that we rethink how we use materials. So, and there's another difference between the energy transition and the material transition, and that is the fact that to meet our targets for 100% circular in 2050, we need to start making different decisions today, because the buildings of our future are moving away from traditional mines to urban mines. So that means that the buildings of today are the mines of the future. The building materials that are in them and the way that they are being able to be demountable and reused is going to determine if we can make the targets in future. So there are different ways in capturing all the concepts around circularity, and the butterfly diagram developed by the Ellen MacArthur Foundation is one of them. So this tries to capture a lot of elements of circularity. So to put this in a little bit of a simpler context, this is also a way to put it. So on the right end, there is the best decision, that is to start and refuse building materials. And on the other end of the spectrum, there is virgin materials, and especially virgin materials with a high impact. We need to try and avoid them. And so then new timber-based, timber and bio-based materials, that is a good solution. And what we see is that is also increasingly feasible solution. So we're actually already having residential high-rise like this Amsterdam residential tower built out of timber. So the really interesting thing about timber is that it's based on this incredible machine being able to store CO2, take CO2 out of the atmosphere, store it into the timber, and then when it's stored in buildings, we can regrow a new tree and actually start to capture more and more CO2 out of the atmosphere and back into the built environment. So what we're trying to do is we're elongating the natural cycle into longer cycles, and actually the idea is that at some point we are also being able to reuse timber so that we elongate this path as long as possible. So this means also something for the way we design now our timber buildings, and so that we design them that they can be reused and reused in different cycles in future. So that brings us to also the other side of the spectrum. So not for all materials it's possible to use bio-based materials. So for some we will be depending on virgin materials. So an example of that is glass. So glass, at the moment there's a lot of glass that's being recycled, but actually about 80% is being downcycled. So going there, losing its value or being landfilled. So for this Lloyd's building in London, what we did, instead of replacing the glass by better insulated glass, we actually took the glass out and we have upgraded the glass and put it back into the building so that it has a really less of an environmental impact. So what we need to do is also digitize our processes in reusing, because if we build now buildings, we need to build them from the materials that are already existing out there. So we can't design everything. We need to understand what is out there and how we can put this together so that it shapes a new building. So we need different design aspects, and also, for example, parametric approaches to support this design approach. An example of a building where it really took circularity to a next level is the People's Pavilion. This is a temporary building which is 100% circular building, and all materials are borrowed and are returned completely unharmed. So what this type of building really teaches us is that it's not only about replacing one material by a less environmental impact material, but actually it's also about changing to different types of buildings, so different types of concepts. So, for example, building with mortar or gluing things together, that should be something that is in future something from the past. And also mixing aesthetical functions with technical functions, that is also something that we really need to reconsider. So this means that we need to change also the way we build them, the way we put things together. So, for example, we need to move towards a plug and play and circular design. And so we design not only for this life, but for infinite life cycles. And we try to use only dry and easy disassemblable connections. And we move away from using unique elements, but built with a limited amount of building blocks that we can just reuse in another building. And also try to maximize flexibility and adaptability of these buildings and building blocks and decouple aesthetics from technical functions. So circularity is a lot. There are a lot of elements that you can use. So to get a better grasp of it and to help lead to better designs, Arab developed the Circular Building Design Toolkit together with the Ellen MacArthur Foundation. And this is basically giving some framework, some type of framework that will help designers to design more circular buildings and to get inspired by this open website that you can find on the internet in this link. And another thing that is going to be really important, like with energy, is that we need to be starting to set goals, even if the EU didn't set really clear goals yet. Like I said in the beginning, stranded asset is really the sooner you start, the easier and the less impactful financially it's going to be on real estate. So setting goals will really initiate change, and starting early is really important. So hopefully in the next couple of years, the building construction industry will be known for being an industry in which change really happens fast. Thank you very much.
Thanks, Krista. So can I just pick up on this issue of reusing building materials? How are you finding insurers react to this? Are they on board? Are you still getting resistance? And on a related issue, I wonder if you're able to give us an update on what's currently being done in the industry with relation to material tracking.
So so to answer your first question on insurers, how they respond to it, so it really depends on the material. So for some materials, they don't really care, like if it is floor finishes, for example. But there are other materials that you can think of that there requires warranties or certification, and there it is really important. And I think that needs a change in the industry. So I think we need to look differently at reused materials. So it has now the image of being secondhand and having less quality. And I think we need to move to thinking of reused materials as just a different mine. So instead of having steel from the mine, you have reused steel coming from reused products, and you get the same warranty. So we see that already happening, that there is a remanufacturing process in which you get the same warranties for the materials. So on the material tracking, what we see now is that we're developing material passports. So based on the 3D models, the BIM models of the buildings that we design, we created a material passport that is delivered with the design. And that's still in a premature phase. So I think what we really need to tackle is using these material passports also for the operation phase, so that we keep them as live, and so that not with every refurbishment the material passport intent gets lost. And it also needs to be updated to become install more relevant information. So really the ingredients of materials, so that we get the best recycle processes. We understand what's in it to have the best recycle processes, and also to understand how it can be dismantled and reused in the future. So we need to add that information.
Thank you very much for that. You will have an opportunity to put questions to Krista during the panel session after our final presentation. But now I'd like to introduce Matthew Prowse, who is Director of Specification and Housing at Knauf Insulation. Matthew.
Knauf Insulation are one of the UK's largest insulation manufacturers. We make non-combustible glass and rock mineral wool insulation. My role, and that of my team, is to consult with architects and specifiers on the best choice of insulation materials for their projects. I'm here today to explain a little bit about the new approved Document L, which is coming into force in June. This is the biggest change to energy efficiency in a generation. There are some very significant headline changes that will impact the way you design homes, though, as you'll see, not necessarily the insulation you specify. Today is about Part L for homes in England. Regulations for Wales, Scotland, Northern Ireland, retrofit and commercial applications are out of scope for this conversation, though they are of equal importance to Knauf Insulation. So what are the most important things architects need to know about the new Part L? So firstly, the last change in 2013 was a 6% reduction in carbon emissions. This time, designs must achieve a 31% reduction in carbon emissions over 2013 levels. This can be delivered through a combination of fabric efficiency and low carbon technology. Secondly, fabric efficiency standards are higher, and there's a new primary energy metric. Primary energy is a calculation of the amount of energy that must be generated in order to satisfy a building's demand. It's significant because it makes a fabric first approach essential, even as the grid is decarbonised. There will be much more scrutiny of as-built quality. The new BREL report, required for every home, will include photographic evidence intended to show build quality. And also, there's an accelerated timeline compared with previous regs changes. Transitional arrangements are at individual building level rather than at site level. Whereas previously we could build an entire site based on the regulation that was in force at the time of the first house built, now larger or slower sites will have to change between one house or block of flats to the next. This applies to all applications submitted after June 2022 and building work started after June 23, only 1 year later. Obviously there's much more to it, those are just the headlines. Much more detailed guidance will soon be available on our website, including a CPD, Part L guide and whole house compliance recipes. Your designs must imminently deliver a much more efficient fabric that stands up to as-built scrutiny. Insulation will play a lead role in every scenario for Part L compliance. It's important to note what Part L doesn't say. Part L doesn't ban gas boilers or mandate the use of heat pumps. Neither does Part L mandate specific U values for walls, roofs and floors. It does, however, include backstop values, as every iteration of Part L has done. These are bare minimums that are already well established. There is a notional building in Part L, but this is just an example specification, an energy efficiency yardstick against which to measure your designs. It's highly unlikely, though, to be the right one for you and your clients. In fact, architects retain the freedom to choose the optimal blend of efficient fabric and low carbon technology for compliance. For example, it's possible to find a route to Part L compliance that retains existing building footprints with a non-combustible material. Or, on the other hand, to choose an approach that prioritises an ultra-efficient fabric to minimise the need for low carbon technologies. It's all about getting the whole house recipe right, which will depend entirely on the needs of your client. So these needs are diverging. As the regulatory picture gets more complex, Let's look at some examples. A volume house builder, for example, will need recipes fully optimised for cost. Their size means they can probably procure low carbon technologies at scale, at a competitive price, and with guarantees of availability. They'll wish to apply a consistent specification to all houses across a development, and on larger developments, this will require a recipe that involves minimal changes or redrawing of plans as traditional arrangements end. If you're working for an SME house builder, they may prioritise simplicity, favouring a more efficient fabric over complex renewables and heat pumps. This could be because they want to stick with what they know, including products and suppliers. Or it might be they're concerned about the availability, usability or longevity of newer low carbon tech. High-rise developments may be much more influenced by the choice of heating system. Limitations on space for renewable technologies such as solar panels mean they're more likely to require an ultra-efficient fabric. And of course there are other regulations to consider, like those related to fire safety. On a bespoke self-build project, the clue is in the name. There will be a very specific set of priorities completely dependent on the client. Some generalisations we might expect are that there may be greater scrutiny of quality and as-built performance. There's likely to be a strong focus on longevity because the client will often be living in, running and maintaining the building for many years to come. And that probably means a future-proof design, not net zero ready, but net zero now. You as the architect will have much more influence in this case. So, a very important point. In all these cases, you as architects will play a critical role as the trusted advisor, helping clients navigate the Part L changes through correct specification. That privileged position means architects have the opportunity to do what they do best and think about the bigger picture. That bigger picture is what I want to spend the final few minutes talking to you about now. Whatever your client's needs, to get the specification right, it's critical to consider how the installation you choose performs in the real world. Not just on paper, in drawings or on calculations, but in each individual home as built. The three key considerations here are measured efficiency, genuine sustainability, and fail-safe fire safety. Earlier, I explained how the new Part L is introducing greater scrutiny of as-built quality. This is just the start of a paradigm shift to a new model where the actual performance of every home is measured. The government has stated as much. Its EPC action plan says they will move to a true measure of in-use building performance. And the new Homes Ombudsman is being launched with fuel and energy performance within its remit, and the power to enforce redress and issue fines of up to £50,000 per home. What this means is that architects must consider buildability in their specifications. How likely is it that the performance you've specified will actually be delivered on site? Does your specification rely on perfect walls or perfect installers? Will the average installer be able to fit the insulation you've chosen correctly? The answer is to choose insulation materials that are more forgiving of conditions on site. To be blunt, ones that are difficult to get wrong. As a general rule, flexible insulation materials that work by trapping air are often more adaptable than rigid gas-filled foam boards. Real-world performance reduces the operational carbon emissions from the building, but that's only part of the equation. Genuinely sustainable buildings consider whole life carbon, including embodied carbon. National regulation on embodied carbon doesn't exist yet, but it is inevitable. And the market's already changing. REBA's 2030 Climate Challenge recommends an embodied carbon target for practices. There are some elements of construction in this country where reducing the embodied carbon will be difficult, but insulation choice is one of the low-hanging fruits. The answer for architects is to specify products low in embodied carbon. You can get this by reviewing data from environmental performance declarations. The third essential real performance consideration is fire safety. We've all seen the devastating consequences when supposedly fire-safe systems fail, and the ongoing pain and stress for those living in buildings that now need remedial works. I don't think we should be designing homes where the fire safety assumes and requires a 100% perfect installation. In high-rise homes, the answer is simple. Developers now only use non-combustible insulation. I think we should apply the same principle to all homes. Design using products that help limit the spread of fire when things go wrong. Using non-combustible materials is the safest choice. And, as we've shown in our SAP calculations, which you'll be able to find on our website, there is always a non-combustible insulation solution to Part L compliance. So let's make non-combustible non-negotiable. As you can see, although the new Part L is about improving the thermal performance of homes, when it comes to specifying insulation, that's only part of the story. To get the best possible compliance approach and insulation specification for your clients, you need to think beyond U values. Yes, you should consider cost efficiency, availability, simplicity, and future-proofing, but also embodied carbon and fire safety, and all in terms of how the building will actually perform in the real world. Consider all of these and you'll find the right route to Part L compliance and ultimately better buildings designed with people and the planet in mind. Thank you.
Thanks, Matthew. So you've explained how the new Part L is going to place a greater emphasis on the way buildings perform in the real world. To state the obvious, that's very much dependent on the quality of workmanship on site. So do you think this is going to lead to a move away from design and build contracts and a return to traditional contracts where the architect has more of a role to play in terms of monitoring the standard of construction work?
Well, that would be nice, wouldn't it? I think it could. I think the question really is, how can the client prove that the dwelling has been built the way it's been designed? So I mentioned photographic evidence in the presentation there. The photographic evidence that's going to be required is going to be an image of each thermal junction type and an image of the insulation type and the thickness. And those photos are going to be checked by the SAP assessor at the point where the energy performance certificate is issued. But at that point, the work will be almost complete. So what if the photos show that the workmanship wasn't up to scratch? I think there's a risk inherent in the proposed process that the EPC can't be issued for that home, in which case, obviously, it can't be completed or sold or rented. So here at Knauf, we've been training and monitoring our approved superfill installers for many years, and we're now launching a digital solution called Kinetic, which is based on scanning QR codes, and the aim is that will help record the details of the installer and the installation and the prototype and everything, and help with compliance. I think the solution for a lot of the large house builders is that they're employing a lot of quality managers who go around the site, but what about all of the other projects? I think there's definitely a role providing more oversight on the works as they progress and helping with the quality management, especially in circumstances where perhaps the client is somewhat inexperienced. I think that could be a really valuable service. So I think, for those architects who choose to, I think there's most certainly more of a role to be played in the coming months after the change to the new Part L.
So please do send any questions you might have for Matthew, and we'll pick them up in the panel discussion after our final speaker, Marion Bailey, who is an authority on sustainable retrofit and a partner at PDP. Marion.
Thank you very much for your introduction. I'm going to present to you today the world of retrofitting and how we can address the energy efficiency in our buildings in the UK. So first of all, I'm going to just put a little bit of context and ask the question, why should we retrofit? And then how we can retrofit, and I will illustrate this with 5 case studies. And finally, go through a couple of points on skills and training and how you can do the same. So first of all, why? Well, you will have read or at least heard about the IPCC very recent report, which has confirmed that we are on a trajectory of achieving a 0.2 rise in temperature, which will have some irreversible effects on our climate. We obviously cannot let this happen, and we have to act, and we absolutely need to act quickly to help keep this temperature rise to a minimum, and hopefully an absolute maximum of 1.5 degrees. So the good news is that we know how to do it, and I will help you understand how we can do it. First, we know obviously that the rise in temperature is very closely related to the rise in CO2 in our atmosphere, and this is the CO2 cumulative curve of present in the atmosphere, and it's an all-time high in the history of humanity. We've got to absolutely go on a very fast descent to achieve net zero by 2050. The good news is we know how to do it. We absolutely do, especially in the construction industry. So I will show you with a few examples. We also are able of great change in our nation, and this little graph shows that in 40 years we managed to dig up all the roads in the UK to install gas pipes and gas boilers and central heating to 95% of our residential properties. So we are able of great change, and we have 30 years to implement this great change. We need to start now, but we are absolutely together able to achieve this. So how? Well, first we need to observe that in the UK, 27% of the CO2 emission come from the use of buildings, and in particular the biggest proportion is the use of residential properties at 80%. So we can focus on this particular type of buildings to have the greatest of effect on curbing these CO2 emissions. So these residential properties are split within certain tenures. So there is 18 million which are owner-occupier, 4.5 million private renters, and 4.5 social rented. So the owner-occupier group will definitely be a very important type of owners to help reduce their CO2 emissions. The particularity that we have also in the UK is that 60% of all homes are older than 80 years or older than 1960s. So this is something that is very specific to the UK, and it's not the same across all European countries. Also, additionally, 21% of the UK residential stock is Victorian, and we love our Victorian heritage. So we need to address this specifically to retain this historic asset, but it is particularly inefficient at retaining heat, and quite often still has single glazing. So we need to make sure that we address this particularly inefficient stock. And finally, 86% of all residential properties use gas boilers, which are obviously using a fossil fuel, and we need to reduce this 80% down to zero. But we know how to do this. So the main focus needs to be on space heating, which is the portion in red in that left-hand side diagram here, which illustrate the current UK average of residential home CO2 emissions. On the right-hand side, you can see that it's reduced by 80%, and this is the result of buildings that have been retrofitted and have delivered against that target. So it is absolutely feasible, but you will see that the main efforts that we need to do is really reduce this space heating the CO2 emission related to space heating is the most important focus to have when we're talking about retrofit. So in measurements, because we need to quantify that reduction, you can see in blue here, and these diagrams are extracted from the LETI Climate Emergency Retrofit Guide, which I have contributed to. The average of the existing residential property space heat demand is about 150 kilowatt hour per meter square per year. We need to absolutely shift this and reduce it to 50 kilowatt hour per meter square per year. So it might sound a little bit tech, but as you are all probably becoming more aware of kilowatt hour, maybe with an electric car, these are measurements that we need to also apply to our own houses and residential stock. So the kilowatt hour will be fundamental to understanding the targets that need to be achieved. So in other words, or in other illustration, you can see on the left-hand side, the current average is 150 kilowatt hour per meter square per year, and is primarily of gas, as we've seen earlier on, 86%. And on the right-hand side, we need not only reduce it down to 50 kilowatt hour per meter square per year, but we also need to make it only using electricity. So we need to what we call electrify space heating. It's not going to be the same targets for depending on which type of property you have. So if you have a flat or mid-terrace, you obviously share some of your building envelope with your neighbors, so it's much easier to achieve a reduction in space heat demand than, for example, if you have a single-story bungalow. And achieving this space heating efficiency is really primarily by insulating properties. And you can see in this image, the building in purple has been retrofitted with external wall insulation, and shows that it's really able to retain the heat inside the building. And the other houses on the right and the left are showing the heat seeping through the wall, because the walls and the windows are not efficient at stopping the heat going to the outside of the building fabric. So we really need to make sure that we can stop the escape of heat through the building fabric. So the LETI guidance is also very good at helping people embark in this retrofitting process by first defining the project and the outcome. It will not be the same depending on where the building is and what it looks like, etc. Understanding the building and the risks. So it's important to mitigate absolutely the risk of the adverse effect of retrofitting. And these are explained again here. We need to also plan and evaluate the improvements, just to make sure that we are absolutely confident in the strategy. And we install and commission properly also all the equipment that we have retrofitted in the building, in particular, for example, the air source heat pumps, and check outcomes by perhaps, if you can, measure the performance of the building and also the comfort level inside the properties, to make sure that you have achieved what you had set out at step one to be doing. LETI is also very good at helping putting key targets for specific elements of the retrofitting process. First of all is to be fossil fuel free, so no longer be reliant on any fossil fuel energy to operate the property. Energy use intensity is another word that you will use a lot in retrofit, and this is setting the LETI is setting the energy use intensity at 50 kilowatt hour per meter square per year. It's also relaxing it, adding a further 10 kilowatt hour per meter square per year if you have for example, a heritage building or very poor form factor. As mentioned, for example, a single-story bungalow, you will have great difficulties in achieving 50 kilowatt hours. So you can have a relaxation of 10. And again, setting other targets for space heat demand, hot water demand, and renewable energy. The column on the right-hand side is illustrating further more drastic targets that are effectively aligned with the Passive House NFIT standard. So a few case studies to illustrate this, how to retrofit. So there is 5 key steps. First, to address the building fabric and effectively the efficiency of your building to achieve this golden number of 50 kilowatt hour per meter square per year. So first of all, we will need to address the walls, the external walls, by insulating the property, then addressing the windows, then bringing fresh air into the property, but efficiently with for example, an MVHR, mechanical ventilation with heat recovery, then airtightness and thermal bridging. So if we take first, the insulation strategy. So we have on the right-hand side here a 1960s apartment building, which has been retrofitted with external wall insulation and new windows. In effect, if you are able to retrofit a building by adding elements and new materials to the outside, it's much simpler. You can occupy the property, and you can also vastly enhance the aesthetic of the building if it's, for example, been left unloved since the 1960s. So here, all the areas in yellow are the retrofitted layers of insulation, and you can see the new windows also adding to the efficiency of this property. On the left-hand side is a situation against a concrete wall, and on the right-hand side, a brick wall. Secondly, addressing the efficiencies of windows will be very important. This is a bit of an extreme case. It's actually a grade 1 listed building in front of you, which is Cambridge House Hotel on Piccadilly, and on the right and the left they're grade 2 listed buildings. But what I'm trying to articulate here is that there is not one size fits all, and you will always have to address the heritage significance of the property you're looking at if you're in a conservation area or you have a listed building, but also if you have, for example, some features in the glazing that you would like to keep. So you need to really assess each of the windows independently to one another. This is the situation of what to do with this left-hand side single glaze casement windows. We've decided in this particular instance to install the secondary glazing. You can also find some fantastic products. Of course, where there's commercial opportunities, the market will react. And here you have a Landvac on the left-hand side, which has an outstanding performance for a vacuum glass at a UG value of 0.5 watt per meter square K. And on the right-hand side, you have another vacuum glass from Fineo, which has a value of 0.7 watt per meter square K. The Fineo has also a heritage range, which gives this sort of wobbly effect in the glass that replicates heritage glazing. So it's very interesting. You can install it either in primary glazing as a replacement of the existing window, or a secondary glazing, both system. It's fantastic to see these kind of products coming to the markets. They are an absolute game changer for the retrofit market. I don't have time too much to talk about moisture in buildings, but obviously when you're retrofitting anything in an existing building, you're modifying the moisture behavior in the building fabric. This is really important and something that you should look into quite a lot of details, so that your building can carry on breathing, and the moisture can evaporates and dissipates in the building fabric in one way or another. Claridge House. So I've chosen this project to talk about the topic of ventilation. So to keep all the warmth that you have produced inside your buildings, you can use a system which is a heat recovery, mechanical ventilation with heat recovery, and this will be roughly 80% efficient at keeping the heat inside the building. So instead of using, for example, an extract and chucking all the air outside with all the energy that you have put a lot of effort in producing, then this system enables to keep the energy inside the building and therefore minimize the demand for a heating system. You see on the right hand side is a utility cupboard which also has the kit for an air source heat pump. So locating these utility cupboards in a retrofit is particularly challenging, but this is absolutely the challenge that we are facing. Princedale Road is a project that achieved the Passive House certification and is largely through the simplicity of the approach, which retrofitted a layer of internal wall insulation, and the Airtightness line followed that layer of insulation as it should, but is also continuous and uninterrupted. So it's been a really fantastic project to illustrate how far we can go into making sure that this airtightness and insulation lines are absolutely continuous, one material throughout the whole building fabric. Then this is Regent's Crescent, a building obviously in London as well, which illustrates here the case of thermal bridging. So we are internally insulating this building, leaving a cavity between the existing masonry and the new retrofitted element that are insulating. But we need to use some software to assess whether the retrofitting measures can affect the internal fabric, and in particular assess the risk of surface condensation internally. So we need to have a really lovely red line or red warm colors inside to the inner side of the property to make sure that we don't have this condensation issue. So using a software like Therm or OpsiTherm will become a lot more common as we are retrofitting our buildings. So just to recap on the 5 key principles through this little illustration of Princedale Road here. First of all, we have a continuous layer of insulation. In this case, it's internal, but it can be external. Then addressing the windows, addressing the ventilation, then having a continuous airtightness and mitigating the thermal bridging. And this is your recipe to achieve 80% CO2 emission reduction in residential properties. Lastly, on skills and training, it's obviously demanding us all to learn a little bit more how to do our job as retrofitters properly, or architects or services engineers. We need to go back to the drawing board somewhat and learn how to do things slightly differently. So the organizations on the screen here are all providing some kind of trainings towards retrofitting. And I would encourage you to contact any of them, and generally, in any case, to upskill to be part of this fantastic challenge of retrofitting the nations. Other publications, there is the Letty Climate Emergency Retrofit Guide on the left-hand side here, a fantastic resource. And on the right-hand side, a book that I have written a few years ago on residential retrofits, which illustrate 20 case studies of different types of housing, of houses, and 20 different ways of achieving 80% CO2 emission reduction in a residential context. Finally, it's all about people, and it's all about working together. So at PDP London, we have decided to train our staff in groups so that we can help each other. And by doing this, we also know what the other person knows, and we're more able to work collaboratively if we train all together. So I would encourage you to train with the people you're working with for best results. Thank you very much, and I hope to see you on a retrofit project. Thank you.
Thank you, Marion. So, talking of training, I'm interested to hear you use the term retrofitters in the same breath as architects and services engineers. So, given the urgency of retrofitting our building stock, is it time, do you think, to recognise the retrofitter as a distinct profession? So, would you like to see, for example, say, a 3-year degree that would bring a whole generation of retrofit literate graduates to the marketplace much more quickly than our existing architectural system can?
Thank you, Isabel. I would say definitely that should exist, a comprehensive course at university. However, we haven't got very much time to implement this retrofit en masse. So I would probably more advocate for the case of a retrofit coordinator course, for example, which any person in the construction industry which has an experience of about 2 years can go on to. And there is several types of training. So a retrofit assessor who would make a survey of the building and assess the risk and plan out the future delivery of a retrofit plan for each of the houses. There's also a retrofit coordinator who's able to quality assure the retrofits, retrofit designers also, which is more aimed at architect profession. And there's also retrofit trade, a course for trades. The advantage of having these last few years of not very much action is that a lot of training has been put together. So the industry right now is really ready to absolutely teach anybody in the construction industry who would like to embark in this retrofit topic. And we need no less than about 200,000 retrofit coordinators. So anybody who's looking for career change, I would strongly encourage to join this retrofit new sector, I suppose.
Thank you. So now I'd like to invite Alex, Krista and Matthew back, and we'll take a look at some of the questions that have been coming in from the audience. I'm going to be joined by my colleague, Jason Sayer, who's been doing an expert job of fielding your questions. So, Jason, what questions have you got for us?
Hi there, Isabel. Yes, actually, we've had a question regarding kind of the skills gap when delivering sustainable homes and indeed buildings in general. Is there a skills gap regarding the more complex but potentially higher performing sustainable strategies that could be installed, such as insulation, perhaps? Oh,
well, Matthew, I'll put that to you then. I mean, we have talked a bit, haven't we, about the need for high quality workmanship on site. Do you think there is kind of the flip side of the question about architects taking on a more active role in monitoring quality? Do we actually have the skills that we need?
I think that the skills have sort of come and gone with various retrofit schemes that have happened in the past that have been government funded schemes. So what you tend to find is there's a large amount of insulation installers get employed and trained when there's government money to fund insulation retrofit, and then when that funding disappears, all those guys go off and do other jobs and you lose that straight away. So there's not a sustained effort to keep those guys and girls, obviously, to keep those people employed and continuing to deliver the kind of energy savings that we really need. So that's perhaps something for government to think about.
So actually, I'll put that to Alex as well. So Alex, at your Agar Grove project, have you found that the skills are available?
Well, they certainly had to develop those skills during the course of the project, and there was a degree of trial and error. So the airtightness testing in some instances didn't perform first time or didn't meet the performance first time round. But then through inspection and snagging and making sure that everything is up to par, subsequent testing thankfully proved that they met Passive House requirements. So I think there's been a degree of learning on the job on that, but I guess now in that case Hill have a workforce that will be more familiar with the demands of meeting Passive House, and I know, and we've already worked with Hill on other projects where we're delivering to the same standard.
Jason, what else have you got for us?
Sure. How have you been working with conservation or heritage bodies when seeking planning to provide a retrofit such as the ones that have been outlined today? Have there been any barriers, and if so, how would you like this to change, if at all, moving forward?
Okay, Marion, this has your name all over it, doesn't it? So can you tell us a bit about the kind of conversations you're having with planners and heritage authorities, and how receptive are they to Enofit and the obvious implications it has for the aesthetics of historic buildings?
So definitely it's been a challenge, but I think the last 24 months has really changed the mindset of the planning authorities, and the fact that most boroughs have now declared their climate emergency. They are a lot more able to listen to how, the challenges of making it happen. And for example, if I just take the elements of the window, which is the key challenge in conservation area or listed building, we have seen several listed buildings being fitted with efficient secondary glazing, including this vacuum glass I was talking about in the presentation. So I think the situation is changing. They are listening, and they are much more willing than before to accept that we're going to have to compromise together with them. So it is changing. And I should also state that Historic England is doing a fantastic work and has published several documents, guidance documents about how to retrofit listed buildings. So definitely the idea of retrofitting is now well in place with these key players.
Okay, brilliant. Thank you for that. Jason, if we can have you back. So what other questions are coming in?
Sure. This question is on the role of IT in the delivery of sustainable homes. Are we really maximising its potential? It was mentioned today that you view digital technology as fundamental to our ambitions to meet sustainability goals. Could you tell us a bit about the work that you're doing around digital twins and explain how this can help clients to realise their sustainable goals?
Krista, it was you, wasn't it, that mentioned digital twins? Do you want to talk, you did touch on it, but do you want to just address that more broadly? How do you see the role of digital twins in actually helping the industry as a whole achieve its sustainability goals?
Yeah, so I think what we miss in the built environment is that we have no reference material. So if you have a building and you get your energy bill, you just pay it because you think that's the energy bill you need to pay, but you don't know if you're paying too much. And this is what a digital twin does. It builds like a digital model of your building, and it just says with a given weather file, with a given system that you have, with a given occupancy, what it should be, what your energy bill should have been in that last period, and you can compare that against each other. So we've done that for example, for a couple of buildings, and when you are comparing these things, like I think a couple of us have mentioned also the insulation of buildings and that not being right, a digital twin with the data that's coming from a digital twin, you can really pinpoint your building is leaking energy, and it is because, for example, the insulation of your building is not performing like it should, or it's a valve being broken. We have all these things in buildings that can underperform, but we just don't know it when they underperform. So I think there is a big job to do in really analyzing and utilizing this data to understand this.
Thank you for that. Jason, we've got time for a couple more questions. So what else is coming up?
Great, we have a couple more. In your collective experience of delivering sustainable places to live, I think it's to everyone, has this had an impact on these properties' mortgageability? And if so, to what extent?
Ooh, Alex. I'm going to pick on you for this, I think. Do you know about, obviously some of the housing is social housing, isn't it? But do you know about the kind of mortgage market and how it's reacting to the kind of homes you're delivering?
I think, well, Agar Grove has illustrated some of the properties are market sale. I haven't learnt of any problems in, and that was particularly, those units were targeted at first-time buyers. So they were getting the Help to Buy in some instances. So those who might usually struggle to get a mortgage have clearly managed to in that instance. I think there's another side to this. There's a mortgageability question, but there's also the attractiveness to the market question, which I think will drive in turn mortgage lenders to take this seriously, because I think buyers are getting more discerning, they're getting more information, as Matthew kind of talked about, and as a result, they're going to start demanding better performing homes. So I think the insurance industry, the mortgage industry, will recognise that and start offering more products that suit.
So that concludes part 2, and I'd like to say a huge thank you to our programme partners, Knauf Insulation, and our 4 speakers, Alex Ely from May, Krista Devan from Arup, Matthew Prowse from Knauf Insulation, and Marion Bailey from PDP, for what's been a brilliant session.